Alright, so today we're going to talk about how to solve a quadratic inequality. So we discussed quadratic equations, the factoring, completing the square, and quadratic formula methods. Today we're going to talk about quadratic inequalities. Now, first thing I want to point out is that you can use the completing the square or the quadratic formula methods to solve any of these quadratic inequalities as well. However, these can be a little more complex of a problem, so I personally selected numbers that only factored to work with instead. If you ever do encounter ones that require something else, the quadratic form is probably your best bet to work with, but completing the square can obviously still work as well. So if you're following along in the textbook, Algebra 2, the Glencoe Algebra 2 book, 2018 edition, we're in section 3.7. So to solve the quadratic inequality, we first solve the related quadratic equation. This is why I'm saying you could have used any one of the three methods to work with, though we're going to focus on only the factoring methods for this one. You're using then the solution to set up these test intervals to see whether the original inequality was to satisfy the situation right here. Because remember, the quadratic equation solutions represent when the quadratic equals 0. So it's possible that if we think of our graph right here, let's say we have this equation like this right here. So at these points it equals 0. Well, to the points to the left of this point and to the right of this point, we're above the graph, so we're greater than 0. Whereas down here, we're less than 0. So you have to be careful. Because if we want to be greater than 0, then anything in this range won't work. So the answer would have to be elsewhere. Because again, remember, any inequality gives a solution set rather than just a solution. So it's a range of values. We need to make sure we're in the proper range. So if we have x squared minus 3x is less or equal to 18. Again, we solve this as a quadratic, so we ignore the inequality. We have x squared minus 3x minus 18 equals 0. So that means when we factor it, we'll have x minus 6 and x plus 3. So our solutions would be 6 and negative 3. So what we do now is, if we now think of it kind of like on a number line, we have negative 3, and we have 6. We want to see where in this number line our solution actually falls. So we need to try test values that lie in these three different regions. To the left of negative 3, we'll use a negative 4. In between them, we'll use 0. It's probably the easiest number to work with. And then to the right of 6, we'll use a 7. And we're going to plug these numbers into the original inequality and see, is it true? Because if it's true, then that region then falls in the solution set. If it's false, then that region does not. So when we plug in negative 4, we have negative 4 squared minus 3 times negative 4 less or equal to 18. So we get 16 plus 12, which is 28. And 28 is not less than 18. So this will not fall in the correct region. We then try 0. 0 squared minus 3 times 0 less or equal to 18. We get 0 minus 0, which is 0, and that's a true statement. So that means the 0, this in between negative 3 and 6 range, will work. Again, one test value will satisfy the entire range. If 0 works, it would have also worked if I plugged in 1, or negative 2, or 5, or negative 1.73, which would have been absurd, obviously, but whatever we want. So now we try the 7. So 7 squared minus 3 times 7. Less or equal to 18, we get 49 minus 21, which is 28, which as we saw earlier is not less than 18. So that means the solution set here would be the answer has to be in between negative 3 and 6. And we're going to include negative 3 and 6 because it's less than or equal to. If it was just less than, we would have to write as negative 3 less than x less than 6. So that's how we solve a quadratic inequality. We solve the equation, and then we set up test intervals to see where our solution set will fall in. Because it's not going to be everywhere. It's not going to be just greater than 6 or less than negative 3 or something like that. We have to take a look at where it really is. So for this one, same idea. We have x squared plus 5x less than negative 6. So we move the negative 6 over and solve the equation. So we'll get x plus 2 and x plus 3, which gives us negative 2 and negative 3 for the solutions. So again, if we look at a number line, -3, -2. Work with -4, looks like -2.5, and we'll work with 0. Ideally, we don't try and use fractions for these kind of problems. In this particular case, we don't really have much of a choice, given the nature of the two solutions. But now, again, we just plug them in and see what happens. So we have -4 squared plus 5 times -4, less than -6. We get 16 minus 20, which is -4, which is not less than -6, so that is not the correct region. We then try -2.5. So -2.5 squared plus 5 times -2.5 less than -6. So we get a positive 6.25 minus, that will give us a 12.5 less than -6. So this is a -6.25 less than -6. And that's true. It's more negative, so therefore it's less than it. And then if we try 0, 0 squared plus 5 times 0 less than -6, we get 0 less than -6, which is false. So this answer, we're going to be in between -3 and 2, just less than, because we're not going to include them. One trick you might start noticing as you work through enough of these, it generally alternates as a yes, no situation. It's not best to assume that, though. You need to be very, very careful, especially when you talk about higher order polynomial functions like x cubed, x to the fourth, stuff like that. But for the most part, it really does follow that kind of pattern. So it kind of is a safe assumption, but I still wouldn't recommend it. We're talking about, it's not that hard to plug in numbers just to make sure. It doesn't take that long, so you really are better off doing something like that. Alright, so make sure you plug in the numbers to actually test out the solutions. Alright, so we have 2x squared greater than or equal to -13x minus 6. So, 2x squared plus 13x plus 6 equals 0. So I'm just going to kind of skip ahead for how this thing actually factors out right here, given that the idea of this video is not to review the quadratic fraction like this, but to talk about how to solve quadratic inequality. So we'll find this will factor out to be 2x, and let's see, it's going to be a 2x plus 1 and x plus 6. So that's also something you can do. Let me just point that out, because that was just something I just kind of did in my head, kind of guessing and checking. You're welcome to do stuff like that instead of the actual full grouping method we talked about, but either way you need to get the proper for quadratics equations. So we get -1/2 and -6 of our answers. So, we do our number line, going from -6 to -1/2. So we'll use -7, -1, and 0. Those are our three test values. So it'll be 2 times -7 squared greater than or equal to -13 times -7 minus 6. So 2 times 49 greater than or equal to 91 minus 6. We get a 98 greater than or equal to 85. That is true. So the first part works. We then try -1. 2 times -1 squared greater than or equal to -13 times -1 minus 6. 2 times 1 greater than or equal to 13 minus 6. We get 2 greater than or equal to 7, and that's false. So that region doesn't work. And then when we try 0, so it'll be 2 times 0 squared greater than or equal to -13 times 0 minus 6. This becomes 0 greater than or equal to 0 minus 6. 0 greater than or equal to -6, and that is true. So in this case, since we don't have a single region right here, and we can't say it's like in between -6 and -1/2, because that's what that is right there. So what we're going to say then is x has to be less than or equal to -6, or x is greater than or equal to -1/2. That's how we write the solution set right here when it's the two opposite regions, not the one that's in the middle. If it's in the middle, it's just simply the nice in the middle of the two numbers. Very straightforward. When it's on the outsides of it, we then need to look at using the OR statement, where it's less than the smallest number but then greater than the base number. Okay? So we're going to take a look at one more. And then that'll be it for quadratic inequalities. So, again, if you want to try this one on your own and just see if it matches up, just to practice, that's perfectly fine. So when we solve this, we move 13 over. 3x squared plus 13x minus 10 equals 0. So we set up our quadratic. It will be a 3x and an x. It will be plus 5 and then minus 2, like that. So we get a positive 2/3 and a negative 5 for our answers. So negative 5, 2/3. So we're going to try negative 6, 0, and 1. So we try negative 6 first. 3 times negative 6 squared minus 10, greater than negative 13 times negative 6. So we work that out. We get 3 times 36 minus 10, greater than is 78. 3 times 36 is 108, minus 10. We get 98, greater than 78. That is true. So the first region's okay. We then try the 0. 3 times 0 squared minus 10, greater than negative 13 times 0. We get 0 minus 10 greater than 0, negative 10 greater than 0. That's false. So the middle region doesn't work. So this tells us then, we kind of guessed that. The first region works, second region shouldn't, so the third region should work, but again, we should still plug in just to be safe. You never know. Sometimes it actually doesn't follow the full pattern. So 3 times 1 squared minus 10, greater than negative 13 times 1. We get 3 minus 10, greater than negative 13. Negative 7 is greater than negative 13. Again, it did follow the pattern. Because it's not the middle region, it's the two ends, we have to use our OR. So if x is less than negative 5, or x is greater than 2/3. Okay, so that's solving our quadratic inequalities. Again, they're kind of annoying. There's a lot more involved than just simply factoring, that we need to use test values to see which regions actually end up working. And always make sure you plug in each of the values from the regions just to be safe. Don't assume it follows the yes, no kind of pattern, or no, yes, no kind of thing. Alright, so that's it for these quadratics. So I'll see you next time we start talking about things along the nature of polynomial functions.